Hello everyone and welcome to Sunup. I'm Lyndall Stout. Today we're getting an inside look at Oklahoma State University's wheat breeding program. We begin inside the milling lab with Sunup's Austin Moore.
It is easy to look at harvest as the finish line for a wheat crop. But the fact is, combines arrive somewhere in the middle of the process that delivers bread to our tables.
This is something that humans eat and depend on for our daily diet. I mean, it's 20% of our protein and essentially 20% of our calories are coming from wheat.
I spoke with wheat breeder Brett Carver in the milling lab of the Food and Ag Products Center here at Oklahoma State University.
We spend just as much time on data produced in this laboratory as we do with data produced in the field. It's the ultimate disappointment to have a beautiful wheat in the field. It has great disease resistance, unbelievable yield potential, but it does not have the potential to meet the demands of the baker or the consumer.
The process starts with the team looking at the kernels, measuring size and hardness before milling the grain to extract flour.
Now, we talk about soft versus hard, but there are still different grades, different finer levels of hardness. So a softer hard wheat, which we would still find acceptable for processing and commercial baking, allow us to generate a little bit higher flour yield because the mill is just scraping that flour a little bit better off the bran.
This is also where they look at protein, both the amount contained in the kernel and the quality of that protein.
Well, when we talk about the kind or the quality of protein, we break that down into about three categories. The first is what kind of dough properties can we achieve from a certain kind of protein, and that protein in wheat is really 80% gluten. So 80% of the protein is gluten. So dough properties are very important, but in addition to that, we're looking at the finished product. So the loaf volume is very important. And then in terms of what that loaf appears inside, we refer to that as the crumb structure. So we're looking at the aerated structure of the inside of the loaf. Some characteristics that the baker would be looking for. We look at the same characteristics in this laboratory.
This machine is called a mixograph. It forms the dough and measures its properties, beginning with the time for peak development.
We don't want a very long mixing time, but then we don't want a very short mixing time. Long mixing times require more energy in the bakery. Energy is a very costly part of the baking process. However, a very short mixing time where this part of the graph would be shorter generally tends to tell us we have a wheat dough. So strength is not there. Okay, now look at the other part of the curve, the descending part. This is where the dough continues to be mixed beyond its peak development. So we're over-mixing it. We're applying more energy than it really needs. So we're looking at the strength of the dough in relative to over-mixing. Here we want a fairly flat curve and a wide curve. That tells us something about extensibility, something about strength.
And that's what they're striving for here. A dough that blends strength and extensibility, which is the ability to be stretched.
So strength allows the dough to contain the fermentation gases during proofing. That's very important. You got to contain the gases. But the extensibility allows that dough to rise during baking. So we want that balance of strength and extensibility, and the mixograph helps us determine that.
If you'd like to see an extended version of my conversation with Dr. Carver and take a closer look at this lab, please visit our website, sunup.okstate.edu.